So a gas phase decomposition of N2O is believed to occur about 2 elementary steps, step number 1 and the step number 2. And they say experimentally the red law is found to be rate is equal to K times N2O5 to the first power. So the first thing you need to do is actually write down the equation for the overall reaction. Okay, so if you write these things down, we know O and O is going to cancel out, right? So on the left-hand side, what we're going to have is actually 2 N2O5 is going to give you 2 N2 plus O2. Oh, sorry, not O5, N2O. So in the beginning, I just added up, right? I didn't actually add in any factors, right? I just added up and see whether it's balanced or not. If it is, then done. Nothing else I need to do. But if it is not, then I need to actually multiply the factors in either your step 1 or step 2. So actually to eliminate the intermediates. You have 4 nitrogen on the left, 4 nitrogen on the right, and then 2 oxygen on the left, 2 oxygen on the right. So it's actually all balanced, right? And then you say experimentally the red law is found to be rate is equal to K times N2O to the first power. That's actually the first question, right? Write down the equation of overall reaction. We know this is actually the overall equation and it's actually balanced already. So there's nothing else we need to do. Identify the intermediates. So what is the intermediate? It's actually the things that cancels out, right? So you know the intermediate is actually just O. The next question is actually, what can you say about the relative rates of step 1 and step 2? Okay, we say if we want to write out the red laws, we need to use the, these are all elementary steps, right? So one of them must be the rate determinant step, which we can use to write out the corresponding red law, right? So let's say, assuming your second step is slow, then you need to write out the red laws. You know, you need to write something like the rate is going to equals to N2O concentration to the first power times O to the first power, right? If the second step is slow, then you know you can just write out the red law using your elementary step. However, when you write these things out, you realize you know your determined red law is like this. And then if the second step is actually a rate determinant step, you can actually get back to the correct red laws. In other words, the second step cannot be the slow step. In other words, your first step is actually the slow step. Let's see whether that's actually true or not. Okay, if the first step is actually your rate determinant step, okay, the slow step, then you know you can write out the rate equations is just equals to your K times N2O. So if the first step is actually the rate determinant step, then you can actually get the red laws. Let's actually agree with the experimental determining one, okay? And what it tells you is actually the first step has to be your rate determinant step. So the first step has to be the slower step compared to the second step. Okay, so what can you say about the relative rate of step 1 and 2? We know the step 1 is slower than step 2. All right, so let's look at the second examples. So under certain conditions, the experimental rate law for the gas phase reaction for the molecular hydrogen with molecular bromine, okay, the reaction is actually like this. Okay, so that's the overall balanced equation, okay? And then they say the rate is going to equal to K times H2 times Br to the 1/2 of the power. Show that the unusual half reaction orders of Br2 can be explained by the following mechanism. So these are the mechanisms, okay? There are 4 steps. Sorry, somehow when I print out, this step 4 disappeared. So please put it back on, okay? So remember the 4 step we talked about. The first step is actually when you add up all your elementary step, you want to get back to your balance equations, right? So when you add things up, okay, you'll realize it did not actually get back to this. The coefficient is actually just not right. So what you need to do is actually you need to multiply 3 here. So when you do this, you will end up with plus 2BR2. That's going to give you 4HBR. Okay, so you can see it's not exactly the same, but if you divide the coefficient by 2, then it actually gets back to the original balanced equation. So that's actually the first step that you need to do here. And the second thing is actually you need to write down the reactants, right? So the reactant was simply just your H2Br2. The product will be just your HBr. Anything that doesn't belong to your reactant or product, it's intermediate. So once you have done this, then we come to the third step, right? The third step is actually find out the slowest step, okay? So under this case, you know your reaction rate, okay, can be simply written as K times your Br times your H2. Once you see this, okay, then you will realize this is actually your reactant, but Br is not. So you need to find somehow you need to find a way to convert your Br back into your Br2. Okay, because Br2 is actually a reactant. Okay, so the things we can use is actually find out the equilibrium relationship, okay, between Br and Br2. So from here you can write your K EQ is going to equals to Br seconds power over your Br2. So you know your Br is simply equals to the square root of your KEQ times Br2, square root of Br2, okay, which is KEQ times Br2, 1/2 of the power. So you need to actually replace this guy with this. Okay, so you know this will be K times square root of your KEQ times Br2 to 1/2 of power times your H2. Okay, and then these two eventually combine and form a final coefficient Kf times your Br2 1/2 of the power times your H2. Then you can show the red law is really proportional to the Br2 to the square and H2 to the first power. So method-wise, it's actually all very similar, okay? If you know how to do these 4 steps, I believe you can just solve all the questions regarding to the mechanism, okay? So refresh your memory, the 4th step is actually first, when you add up all the elementary steps, you should get back to the balanced overall equation, okay? Then identify your reactants, identify your products, identify your intermediate. That's your second step. Third step is actually write out the red law using the slowest or the rate determined step of your elementary step. Okay, so just write out the equations write out the red law based on the equation. Okay, and then fourth step is actually replace the species in your red law that doesn't belong to your reactant. Okay, using equilibrium constant. Okay, then you can actually get the final red laws. and that will be actually the overall flow, how you can actually solve all these mechanism problems for this chapter.